So I'll try to be quick. We said I'm going to be covering a few topics, but first of all, let's start with PyAnsys geometry, right? Similarly to our other PyAnsys libraries, this specific library is a wrapper for the various Ansys geometry services we have. Most of you might be familiar with Ansys Discovery and SpaceClaim, of course, but there's another one, which is the DMS, or what we call geometry service, which is a purely headless solution, and it also comes with the Ansys Unified install. You can install it with various flags. Anyway, for any multiphysics workflows, CAD is always the first step, and with PyAnsys geometry, we are addressing that void that was currently there in our ecosystem. And mostly this library, what it's doing, it's exposing the underlying product API. If in comparison to other libraries like PyMePDL or PyMechanical, PyAnsys geometry has its own native API, and it's performing identically calls to the underlying coded library we have for SpaceClaim and Discovery, making it much more performant if you use the native API. But you can also use the scripting language that you might be familiar with for both SpaceClaim and Discovery. Anyway, PyAnsys geometry is also characterized for providing several client-type features for curve evaluation. We also have many mathematical objects and a lot of visualization features. And in the end, the way this library works is that it can connect to several products, like I said, SpaceClaim, Discovery, or the geometry service. But the goal is that your final script is independent of the backend you connect. So this would be basically the overview, right? We've got the PyAnsys geometry Python library there, and then an intermediate layer that we call the API server that allows the connection to the different products. So as a user, you would only be coding with the PyAnsys geometry library, and then you could run your script against Discovery, SpaceClaim, or the geometry service. We've been growing a lot the native API. You can see on screen various features that are natively supported. We can perform imprints, create name selections, do modeling operations at large, both scaling, mapping, mirroring, revolving, and also a lot of the repair and prepare operations have been imported into the native API. Apart from all these operations, like I said, we also have the backdoor for using the scripting API of SpaceClaim and Discovery, and you can still use your traditional Discovery or SpaceClaim scripts in combination with your PyAnsys geometry script, so that you can progressively adapt to the native API and also request new features, right? Like if you've got a SpaceClaim script that does a certain operation that is not available in the native API, we encourage you all to submit an issue to our repository, and we will work on supporting this this API natively. So this is a brief example on how the library works. We've got a sketching part in all our modeling operations. So we will define a plane. Let me take the cursor. I don't know if you can see my mouse. Probably you can, but anyway. So on line 7, we've got we're creating an origin, and we're also defining a plane. And on that plane, we're performing a sketch, and where we are just drawing a very simple circle, right? And then we just do sketch plot, and we would get the plotter on the right side of the slide. That's the first operation, right? When you start modeling, you create a sketch. Now, the next thing would be, okay, let's extrude our sketch to create a 3D body. At this point, we have to launch our modeler. This would be a very similar command to what you do when you launch Fluent, launch ADT, or launch MEPDL. In this case, we are launching what we call the modeler, which in our case, it can be various backends. And this function will take the one that's available from all of them. And if there are plenty available, you can either select which backend you want, or let the function decide, which will try to get you the most optimized backend. Then once we launch the modeler, we create a design and we tell the design to extrude our sketch by a certain distance, like we can see on screen. And finally, when we request the plotting operation, this would be the plotter that we get using PyVista, and we can interact with it. Finally, once we have created our design, we would export it into a format of our choice. In this case, SC.x, we support a various set of samples, of formats. So this is the landing page of our documentation. We've got an examples site with more complex ones in case you want to start playing around with them, and we will be running a few of those now as well. I will be sharing the slides like all my colleagues, but we recommend that you start with the one-on-one examples. And then we also have some applied examples, which are like real life use cases or industry use cases. And we also have a lot of examples in combination with other PyAnsys libraries, which will be the second part of my presentation. The full API reference is at this link. And yeah, if you have any bug or enhancements, or you want to start learning how to do certain operations, we encourage you to open either issues or discussions in our repository. And with this, I'm going to start sharing my screen now. Okay, yeah, got it. Yeah, this is the repository, this is the documentation, and I'll be covering a few of these examples, which will run quickly. So this is the simple example that I presented before. If I run the script, we will see the plotting taking place in just a few seconds. I think it's currently loading a few things. Come on. Oh, maybe not. Ah, here it is. Sorry. Takes a bit the first time. So, for example, this is the sketch that we created the first time. Our plotter has certain tools for the different views that you want to select. We also have some gridded operations. We can also take screenshots. We can also perform measurements on our plots. Anyway, once we do the sketching, afterwards we will be launching the modeler, creating the design, and extruding the sketch. And this is the kind of body we just extruded, okay? And finally, if once I close this window, we will be triggering the export to the file requested. And we can see that it showed up right here in my outputs folder. Let's do some more complex ones. I know I'm running a bit out of time. So let's start with the knockout airfoils. This is one of our applied examples. And well, this is running. I'll demo briefly what it does. But basically, we have a NACA airfoil sketcher, which given a certain number of points, it provides our list of points that define our NACA airfoil. For those of you that are familiar with it, are not familiar with it, sorry, this is basically the cross section of an air wing. If we close this function, if we close this plotter and we proceed to the modeling operation where we're extruding our initial sketch, this is a 3D version of the airfoil that we're getting. And this one, we will be exporting it into various formats like FMD and SC.x. The good thing about this is that you can now programmatically, draw different NACA airfoils. For example, in the first sketch that we're seeing here, the airfoil is 0012, but now once I close it, we will be running 6412, and we can see that. I mean, those numbers, so just so that you know, they represent the camber line and different parameters of the airfoil, and the profile has changed effectively. So yeah, and we can see on the output side the files that have come out of it. Now, once we have our 3D body, we can prepare this 3D body so that it can be consumed by Fluent. And this will also serve as a gateway to the workflow examples. I won't be running it just because of lack of time, but basically on these lines here, we are going through the model we have, and we're creating the different name selections for the outlet of our fluid, the inlet of our fluid, surrounding faces for our airfoil, all these things. And this allows us to prepare our files so that it can be consumed easily by Fluent. If you want to see more examples on how to combine PyAnsys libraries, we also have this web page. It's called PyAnsys Workflows. And if you go to the examples, you can see how we are combining different products. Currently, we only have 3 of them. And I think Herman presented this one previously, specifically the mechanical part. But these examples show how to chain together executions from PyAnsys Geometry, and then its outputs are consumed by PyMechanical, and then its outputs are consumed by PyDPF. Depending on the library, well, we've got different steps. So I'll be covering now the NACPy Airfoil one through the workflows page. So this is basically the same example that we just ran. Here we have prepared our solution, with the volume, with the fluid volume and the different name selections and so on. And then if we proceed to the mesh generation, we can start executing our Fluent script based on our outputs. And well, we can see here the different outputs coming from Fluent and so on. All these examples, they are downloadable. You just go to the end, and then you can download this specific example in the format you prefer, and you can give them a try locally on your site and provide us your feedback. And David, I think I can probably stop here so that DPF has enough time as well. If you have any questions, feel free to share them in the chat.